Today we're going to be looking at SimCalc.js, which is a hard jail challenge from San Diego CTF 2022. The jail category is slightly uncommon in CTFs, but the basic idea is that you, the challenger, are given the ability to execute your code in some restricted environment. The goal then is to be able to bypass the limitations on code execution, which is also known more colloquially as jailbreaking. Because this is a hard challenge, we can expect some domain-specific knowledge and just a little bit of ingenuity to be required here, but I will do my best to justify the various steps I take to arrive at my solution. Also worth mentioning, there are many possible solutions here. I'm only going to be showing you one, maybe two different approaches that I think give you really good tools for other challenges like this. If you want to take a look at the community solutions, you can click the link in the description to get to this page, and then you can browse these write-ups at your leisure. Anyways, let's get started by reading the original prompt. We ported our state-of-the-art calculator to Node.js because we were tired of Python's security issues. And that's it. By itself, this might be a little confusing. The prompt is referencing the other challenges in this category that are also called SimCalc, and those other challenges are written in Python, while this one is written in JavaScript. Speaking of, we actually do get access to the source code for this challenge. This is the whole thing. It's less than 40 lines of code and has no external dependencies to worry about. Rather than sit here and read it, let's just run it. When we do, it says, "Welcome to SimCalc.js for all your math needs." We can test it out with a quick 2+2, and without a calculator, I'm not 100% sure, but I think 4 is correct. We can tell this is more than just a calculator because if we mash our keyboard, we get a plain old JavaScript reference error. This program is essentially executing any JavaScript code we give it, although presumably with some restrictions we will be bypassing. It also appears to be maintaining state between calculations since we can actually declare normal JavaScript variables and then reference them later. Let's go back to the code and see if we can't figure out what our goal is. If we just search for the word flag, we can see that there's apparently an environment variable called flag, and that there's probably a good chance that this is what we are trying to retrieve in our limited context. In most jail challenges, the goal is to pop an unrestricted shell on the victim computer, but in this challenge, it looks like it will suffice if we manage to read this environment variable. We can try to access it in our REPL, but we immediately get told off for using illegal characters. We can actually see the parts of the code that enforces this check. It tests against a list of allowed characters, and if it finds anything else, it prevents the execution. This is a common restriction in jail-type CTF challenges, and the solution is often to abuse esoteric syntax features of the underlying language to do things that would otherwise be impossible, like accessing object members without using the period character. That said, I would actually encourage a different approach in this case because there's quite a bit going on aside from just the character restriction. I think it would be a good idea to just comment out this entire check for now. There's no reason to fight against the character restriction while also figuring out the other features of the jail. It's important that we make sure we know what we're trying to do before we worry about how we're going to do it. When I run the patched version of the jail, I'm also going to pass in a dummy flag environment variable so we know when we've broken the jail. With the character restriction lifted, I should be able to type in process.env.flag. Weirdly, though, it doesn't complain that flag is undefined. It says that process is undefined. The variable called process should be globally accessible in every Node.js program. If I type this into a vanilla Node.js REPL, process.env contains the environment variables we are looking for. So, what's going on here? Thankfully, we don't have to look too hard. In the source code, we can see that the input we provide is being run in some kind of VM. A VM in Node.js is like an isolated process environment for executing JavaScript. You're able to instantiate these VMs with a context of your choice, which in this case is being configured as nothing, just an empty object. Because of this, we don't have access to any of the variables that would normally be in the global scope, like process. We can also see that code generation is disabled, meaning we can't do things like run arbitrary code in an eval statement. We can actually try that out, and we'll get the error that code generation is disallowed in this context. Well, at this point, the jail seems pretty airtight. If you didn't already have experience with this sort of CTF challenge, it would be understandable to give up. But it would also be a waste because all you really have to do here is Google it. If I search for JavaScript VM escape, the first result I get is a large gist document explaining how the VM module in Node.js does sandboxing. It also explains all the different ways to escape. You should take a look at this, but I'll go ahead and summarize. If we type this into the REPL, it will return a plain old empty JavaScript object. This is the same empty object that was being passed in as the global context in the original source code. Every object in JavaScript has a constructor which you can access by simply typing .constructor. It's just a function called object that contains native code. But functions are objects too, and that function itself has its own .constructor member, which is a function called F function. Now, this function called function has the unique and exploitable property that any string you pass into it will be evaluated just like the eval function. Despite the fact that code generation is disabled, we can actually pass arbitrary code into this function constructor, and it will be turned into a function that we can then execute. And this is because the function constructor, or rather this function constructor, does not belong to the sandbox context, but the original unsandboxed context surrounding it. This empty object that we're accessing with the this keyword was technically created before our jailed context ever existed. In addition, code that has been executed by this function is executed in the original unsandboxed context and should have access to the original process environment variables. If we print the value of process.env.flag, it'll give us exactly that. So now at least it's clear what we need to do. If we can find a way to execute this line of code while bypassing the character restrictions, we should be able to solve this challenge. So now that we've figured this part out, let's turn those restrictions back on. First, we can try to just type out this.constructor, but we immediately trigger the character restriction. The invalid character here appears to be the period. So the first problem we need to solve is how do we access object members without using the period character? We also need a way to declare strings since we'll be passing one into the function constructor. Unfortunately, we don't seem to be allowed to use any kind of quote characters, which is particularly painful. This is problem 2 we need to solve, but if we can solve these problems, we should be able to solve the challenge. The first one isn't too bad. It's fairly well known to JavaScript developers that you can access object members like how you access dictionary values in Python. Just index them with a string containing the key. Unfortunately, this brings us right back to problem 2. We can't declare strings. This problem is a little bit harder to solve, but I think there are actually quite a few ways around it. I think the easiest to understand way is using the string constructor. If we invoke the function called string, JavaScript will coerce anything we pass in to be a string. For example, if we pass in true, the returned value is not a Boolean, but rather a string containing the word true. I can prove this to you by indexing the individual characters of this string like so. See, the letter T. Well, this feels promising. We might be able to generate every character we'll need by getting creative with various JavaScript built-ins and indexing each character individually. In fact, this is exactly how the esoteric language called JS Frick works. If we visit the source code, we can see that each character is mapped to some unholy code gulf that produces that character when executed. Spoiler alert, this tool won't work on this challenge because the exclamation point is not an allowed character. We do, however, have access to quite a few characters that JS Frick doesn't use, so there's a good chance that we can do something that is a little bit less painful than this. The hero of our story is the division symbol. This is a calculator after all. Consider, however, that we can also use this character to create regular expressions. When you pass a regular expression into the string constructor, it's just like creating a string with those contents. The only downside is the slashes at the beginning and end. Because of these, it kind of forces us to get one character at a time by indexing. One approach would be to cram all the characters we need into one big variable that we can index freely. This actually totally works, albeit slowly. Technically, we have everything we need to start accessing object members. For example, you can create the string constructor with the following sequence. If we use this string on this, we can finally start getting somewhere. That said, I have one more trick up my sleeve that will make this go just a little bit faster. Check out this sequence. It's just the word source. What's magic about the word source in JavaScript is that it's the name of an object member on regular expressions. It should return a string containing the regular expression pattern without the slashes on either side. This means we can now just skip the alphabet entirely and write any string we want as a regular expression and then just access the source property. Using this technique, we can access the function constructor quite concisely without using any period characters. The only hurdle left, then, is to figure out how to create the payload string. The main issue here is that the payload string contains characters that we can't type, namely the period. To solve this, we can use the function string.fromCharCode. This allows us to write any character as its corresponding ASCII number. If we store this function in the variable f, we can concisely create a string with any character, including ones that we can't actually type. For example, F46 is the period character. F100 is just the letter D. Now we can create the entire string, but doing this one character at a time is a bit painful, so I'm going to open up a new Node.js REPL so I can quickly generate this. All right, first I type the payload I want to encode directly into this window. And then I use the split function to split the string up into its individual characters. Then I can use the map function to convert each character into its character code. Then I can add a format string around it to turn it into the string of the function f being called on that character code. Finally, I can join that array of strings with the plus character. Now, I should be able to copy this encoded string into my jailed terminal and get the payload I'm after. All that's left then is to provide this as input to the function constructor, call the function, and we will receive the flag variable. Now that we've developed our exploit, all that would remain in a CTF setting is to use this payload on the official challenge to get the real flag. That's all I have today, but if you want to challenge yourself, see if you can solve this without using regular expressions. Your hint is that there is a very obscure, deprecated JavaScript statement called with that may be an even simpler alternative.